So this is a different turtle's journey, and this will help us prepare for assessment number 2. So let's look at this new graph. We want to find the rate of change of interval A. So here's interval A. It's the first part of the journey. And when we find rate of change, we need to find perfect points. So on this line segment A, I see that 0, 0 is a perfect point. I see that this point here, 1, 2 is a perfect point. This point here, 2, 4 is a perfect point. And this point here, 3, 6 is a perfect point. So you can choose any two of those perfect points. I'll use these first two, 0, 0, and the point 1, 2. Sorry about that. Okay, to get from 0 to 2, we have to add 2. So that's the change in the y. That's the change in the y. To get from 0 to 1, we have to add 1. That's the change in the x. And 2 divided by 1 is 2. And we have the change in y divided by the change in x. We said that y represents feet and x represents seconds, so 2 feet per second. What's the domain and range of line segment A? So line segment A starts here and ends here. Domain is all possible x values. This line is continuous, so I'm going to use my inequality symbols instead of just listing its points. And the smallest x value of this line segment is 0 seconds. The biggest one of this line segment, this is the largest x value of our first line segment A, and that's 3. So the domain of line segment A is 0 to 3 seconds. The range of line segment A has to do with the y values of these 2 points. So which y values work for line segment A? Again, it starts when y is 0 feet, and it ends here when y is 6 feet. So the range is all y values between 0 feet and 6 feet away from the water. What's the rate of change of interval B? Here's interval B. These are 2 perfect points. There's also a perfect point here, right in the corner of a box. Let's use this one and this one as our perfect points. So this one is 3, 6. This point is 5, 6. Whoops, I didn't mean to write a dash there. So the change in the y values, to get from 6 to 6, we have to add 0. The change in the x values, to get from 3 to 5, we have to add 2. So our rate of change, 0 divided by 2, is 0 feet per second. So at that interval, the turtle is not moving at all. How do we rate the domain and range of this same line segment? So what are the x values of this line segment? The smallest x value of just this segment is 3. The largest one is 5. And then the range talks about our y values. So the y values here are both when y equals 6. So our range here is just y equals 6. Another way of looking at this would be if I had kept the coordinate labels on here like we used in the last slide. And we said the first one was the point 3, 6, and this was the point 5, 6. So our domain, the x values, were between 3 and 5, and the range, the y values, were always going to be 6. Rate of change of interval C. Here's interval C right here. find perfect points. This is a perfect point. This is a perfect point. This one in the middle is also a perfect point. So we have 5, 6. You can use any of the perfect points. I'll use this one that looks like it's 7, 4. To get from 6 to 4, we have to subtract 2. So our change in y is -2. The change in x, to get from 5 to 7, we have to add 2. Change in x is +2. So -2 divided by +2 is -1 feet per second. What does that -1 mean? That just means the turtle changed direction, and now he's walking back toward the water. What's the domain and range of line segment C? So let's see. The domain is any x value between, the smallest x value of C is 5, the largest is 7. And the range, the y values of line segment C, whoops, let's keep our points there. The y values, the smallest one is 4, and the largest one is 6. So y can be any number between 4 and 6, including 4 and 6. Interval D, what's the rate of change here? This one also has a rate of change of 0. I have the coordinate point 7, 4, the coordinate point 8, 4. To get from 4 to 4, we add 0. And 0 divided by anything besides 0 gives us 0 feet per second. So this turtle stops again for a second time at D. What's the rate of change of E? Can find, here's a perfect point, here's a perfect point, here's a perfect point. So I'll choose this one, 8, 4. And this one here is 10, 10. So 8, 4, and 10, 10. To get from 4 to 10, we have to add 6. Whoa, what just happened? Here we go, add 6. So that's our change in y. To get from 8 to 10, we have to add 2. That's our change in x. 6 divided by 2 is 3. So our rate of change in interval E is 3 feet per second. And lastly, interval F. Spoiler alert, this turtle stops again at interval F, right? To get from this perfect point to this perfect point. So we have 11, 11 to 12, 11. He didn't change distance at all. Even though time went by, his distance didn't change, and the change in y was the distance. 0 divided by 1 is 0 feet per second. So what's happening in the time interval of 5 to 7 seconds? So here's 5, here's 7. So during that time, that's when we had a decreasing slope, decreasing rate of change. It was going down from left to right, decreasing, which meant that the turtle changed direction and was going back toward the water. So you can take time to make up your own story about this turtle, or watch this animation for an idea. So our turtle starts off at 0, 0 in the water. He starts walking for 3 seconds, then he pauses for 2 seconds, then he walks backwards, then he pauses for a second, and then he goes as fast as he can, and then pauses in the last bit of his journey. So this story about the turtle was saying that the snakes were causing him to move backwards to protect himself, and then to go even faster so that he could get out of the way.